Lastly for our segment, we have port mirroring. So what does port mirroring do? Well, port mirrors are also known as switch port analyzers, also known as, you'll hear them referred to as span ports, switch port analyzers. Now, switch port analyzers, span ports, are just going to be on a switch, but we can set up port mirroring not just on switches, but we can also set up port mirroring on our other devices. We could set it up on our routers or our bridges in order to view data that's going across our devices. But span port is what you'll hear when we're talking about switches, and very often port mirroring is done on switches because switches are very good at managing data, and they're very good at down from routers, they're very good at sending data and managing where it came from and where it needs to go. So when we're sending data on our devices other than a hub, our devices are just going to send the data to the port that they need to. So in the case of our switches, when we set up a switch, for the first couple seconds, our switch will act like a hub and send data to everyone connected to it. But after our switch starts to make up its tables and it determines that, okay, on port number 1, I have computer A, port number 2, I have computer B, port 3, I have computer C, and so on. Our switch is going to determine that when computer A sends a packet to computer E, our switch is just going to take that packet and send it directly to computer E. The only packets that you're going to hear are packets that are just being sent to you and packets that are being sent broadcast to everybody. So this puts us at a disadvantage if we're trying to do diagnostics on a switch, or sorry, diagnostics on our network. If for some reason we need to sit down and we need to capture the data that's going across our network and view it and analyze it, we can't do that on a switch like we can on a hub or on a bridge or on a router, because the data is only going to go to the ports that they need to go to. So port mirroring, and for switches, span ports, allow us to set up ports that have all the data mirrored to it. Now, we say all the data here because all of the data can be the max data that we capture, and then we can also capture only certain ports if we're trying to isolate and diagnose only traffic on certain ports. So this captures network data, and it's very useful for diagnostics, research, or setting up IDSs. Now, an IDS stands for an intrusion detection system. An intrusion detection system is a device that we put on our network, or a computer that we connect to our network running a program that sits there and it analyzes network and it says, whoa, that looks bad. I need to flag this. I need to report it. Intrusion detection system. That D is very important because the D standing for detection means that that device isn't going to do anything about it other than report it. An intrusion detection system isn't an antivirus. It isn't a malware remover. It isn't going to see bad data going across our network and say, whoop, I need to take that. So that's why we can set up IDSs on mirrored ports, because if it was an IPS, an intrusion prevention system actually stops those attacks. That would have to actually be in between us and wherever the data is coming from. If we're just having the data mirrored to us, it's just a copy of the data. We can't take that packet and say, oh, I'm going to discard that, because it's already gotten to where it needs to go. So an IDS just sits and watches and raises warning flags. An IPS actually needs to be on a location where it can, it's taking traffic, and if there's something bad, it stops it. So a little bit of an introduction to IDSs and IPSs, which you don't need for this particular module, but it's good to know. But anyway, port mirroring allows us to capture that data and have it sent to different ports. But we also need to know that devices can't talk on this port. Now, why is that? Well, these devices can't talk on this port because mirrored ports are set up just to have data sent to it, capturing it from all of our other ports. If we tried to start sending data on a mirrored port, and we tried to use a mirrored port as an access port, then when we're sending data out and then receiving responses, we don't know the difference between data that's being sent just to us, or data that, or just to that mirrored port, or data that's being sent to that mirrored port because it's copies of other data. So mirrored ports are going to be set up just as capture ports. So let's take a look at our diagram to better understand port mirroring, because I just blathered off a whole bunch of information that you may not even understand. So let's actually take a look at this in practice. So we have a switch here. We have our network diagram. We have a switch and we have a router. We have on our network diagram 7 computers and a router on ports 1 through 7. Now one of our computers is blue because that computer is set up on a mirrored port, on a span port on our switch. So we're not going to label this computer with a letter. We're just going to label this computer with an M for our mirrored computer. Actually, we'll change that. Our port 7 is going to be 7M for our mirrored port, and this computer is going to be computer W for Wireshark. We're going to have Wireshark running on this computer. So sorry for the little bit of confusion there. So all of these computers are set up on a standard port, on a standard switch, to be able to talk to each other and be able to talk out to the internet through our router. They're all set up on ports 1 through 6, and our router is set up on port 8. So we have a couple different computers over here. We have computer E as a server. The rest of our computers are workstations, and we're running into some problems where we're having some data going on. We're having data traversing our network that's causing some problems. Maybe this is malicious data. Maybe we just want to capture and see if we can check and see why our network is so slow. There's some reason where we need to do some diagnostics on our switch. So we set up port 7M as a mirrored port. Now when we go into our switch configuration, we'll be asked for a source port and a destination port. We need to know what the source for this mirrored port is going to be. So we say, okay, I only want to see the data that's going over port number 5, because port number 5 is connected to my server. So I only want to see the data that's going to port number 5. So we'll go in our switch configuration, and we'll say under our mirrored port, our span port settings, or our port mirroring settings, depending on what our router configuration looks like, and say I want source port to be 5, and I want it to send to port 7. So now port 7 is a mirrored port. We're running Wireshark on this computer, and this computer can't connect to the internet because it's only connected to a mirrored port. So it's only going to be receiving data, mirrored copies of that data from port 5. So we have all of our configuration set up. Our source port is port 5 that our server is connected to, and our destination port is port 7. So let's take a look inside our router now and remove our router symbols. So we have our little router control chip here that's going to direct traffic, direct data where it needs to go. And our server is going to send a packet to go to computer C. So it's going to send the data to its port, and then our switch brain is going to say, okay, I need to send this packet to computer C because that's where its destination is. But I have a rule here that says I need to mirror all this data also over to port 7, where my mirrored port is. So I'm going to send this packet onto port 3, but I'm also going to send a copy of the data, the packet that I'm sending over to port 7, so that my device on port 7 can read it. Same thing if I have port 3 talking to port 5. Any data that's being sent from or to port 5 will also be copied to port 7. Now let's say I need to find all my network traffic. I need to determine what all my computers are saying. Well, then I'll write rules in my switch that say port 6, port 5, port 4, port 3, port 2, port 1, and port 8. I want all that data to be copied over to my workstation here, to my Wireshark capture. Again, what does this do for us? Why do we want all of these copies of data in our switch to be sent over to this workstation here? Well, again, this workstation can be running Wireshark. It can be looking at these packets, and we can search through it manually and see if there's any irregularities. It can be running an IDS. It can be running an intrusion detection system where it checks all of our packets and sees, okay, is any of this data malicious? Is any of this data bad? Should I raise any alarms? So port mirroring is very useful for these diagnostics and for doing this doing our research. So port mirroring, also known as span ports, take all of our data and they send it to where it needs to go, but they also make a copy of the data and they send it to our span port. They send it to whatever device is connected to our span port. And this all has to be configured within our switch. Now, just because we're setting up a span port doesn't mean that our network is going to slow down. If we have a lot of traffic going to our span port, the only limitation, the only downside that we'll really see in network traffic is our span port may drop some packets, and if it's having too much data pushed to it. So if our switch is making copies of all the data from 1 through 6 and then port 8 and sending it to span port number 7, and our span port says, I can't handle all this data, and just drops some of the packets, then the only thing that will be affected is our capture going on our workstation. Because this data is just copies of data, none of our other data packets going anywhere else are going to have any problems. So then our last thing for our span port, let's say that this IDS, this intrusion detection system that we put on span port, that we put on port 7, our mirrored port, span port, we need this data to be able to be sent out to the internet, or sent over the internet to us. Or we need this data to be able to send to our workstation. Our admin workstation is workstation A, which I wrote again. But what can we do? We can't send data back over this mirrored port. This mirrored port is receive only. Well, what we're going to do is we're going to have 2 network interface cards in this device here. One network interface card is going to be for capturing, and the other network interface card is going to be used for actual network activity. So we need a second network interface card in our computer, plug in a second internet cable to our computer, and plug that into a different port. So we have port 9. And that port, we may even want to set up port 9 also sends copies of its data to port 7. But now our computer, our Wireshark workstation, or our IDS, whichever we have set up here, not only receives all of the copies of data that's being sent around our switch, but is also sending out informational packets or sending out alerts, or able to connect to the internet over its second network interface card over port 9. So if you've never set up a mirrored port, never set up a span port before, and you have the resources to, and you have the chance to, it's a great way just to set up a span port and be able to, again, with permission, and if you're using the right resources, you don't want to disrupt your network activities just to play around, essentially. This will give you, this will let you see the traffic going over your network. You'll be able to look at all the traffic and say, wow, I recognize this packet, or I recognize this port number, or this protocol, and check out all that different data that's going on your network and see if you can identify anything. So, thank you for joining us here today on Cyber.IT. Today we talked about routing and switching. We talked about everything from all of our different switching devices, like our bridges, our switches, our hubs, our repeaters, and all of the different concepts, and well, not all of the different concepts, but a lot of the different concepts related to routing and a lot of the different routing properties, protocols, how they set up their dynamic routing tables, and essentially how our routers talk to each other and find the best routes and the best paths to other networks. So hopefully this information is helpful, and hopefully this information will help you in your journey to be able to better work on your networks and better diagnose your networks and know how networking works. And we hope to see you again here next time on Cyber.IT.